Hello everyone, Veruna here, and welcome to another KTaNE modern module tutorial, this time on the module Cursed Vault. This module is very similar to another module of a similar name, Combination Vault. These modules are pretty much identical in the solving process, except for the fact that Cursed Vault has one little twist. The goal of a module is to set these four dials into certain cardinal directions and press this key button to unlock the vault. That will take off one of the locks present on the vault. If you do this for 3 stages, the module will solve. However, every time you turn a dial, the number in the center decreases by 1. If it reaches 0, you just won't be able to turn any more dials, and you're going to be forced to press this button to reset. The thing that makes this module different from Combination Vault and way more difficult is that in Combination Vault, if you were to press a dial, it would turn itself clockwise and then has a chance to turn a different dial either clockwise or counterclockwise, and would always be consistent. So this one turns itself clockwise, and this one will always turn itself counterclockwise. In Cursed Vault, the trick is that each time you press a dial, it will pretty much alternate between 4 different states of how it rotates. So if I press this once, it turns this one 180, this one I believe was clockwise, and itself clockwise. But if I press it again, suddenly this one got rotated. And it alternates between 4 of these, so every multiple of 4 is going to be the same. So I just did 4 inputs here, so the next one again should turn this one 180, this one clockwise, this one clockwise. To begin with, I'm just gonna note down the initial positions. I'm gonna be using numbers instead of cardinal directions, using north and then going clockwise as digits 0 through 3. So 0 is north, 1 is east, 2 is south, and 3 is west. If you cannot figure out what direction it is from the triangle, there's the cardinal direction above the dial. So I'm gonna note everything down in a grid, like this, for every dial. So the rows here are gonna be each independent iteration of how many taps of that dial it has been, and each column is just gonna be for every specific dial. So let's start with the top left. After 0 taps, its directions are 3, 3, 2, 3. Because north going clockwise, west is 3, and south is 2. Now let's press it once. Now it's 0, 0, 0, 3. Now press it again. 1, 1, 0, 1. Press it again. 2, 2, 2, 2. Interesting. And then press it once more. And now it should be back to 3, 3, 2, 3. Yes. Now let's do the same for the other dials. Top right, after 0 presses, it's just going to be the same as this one. In fact, that's going to be true for every single one of these. Press it once. 2, 0, 3, 3. Press it again. 2, 1, 1, 3. Just making sure, because it's very easy to get these ones wrong. Yeah. Again. 3, 2, 0, 1. Again, should bring you back to 3, 2, 3, 3, 2, 3. 3, 3, 2, 3. Yes. Now the bottom left. 0, 2, 3, 0. 1, 3, 0, 3. And 2, 2, 1, 0. back again to this. Bottom right, 0, 1, 3, 0, 1, 3, 0, 1, and then 2, 1, 1, 2. So now we have our positions where of what position a dial goes to after every press. Now what we're going to do is find the actual offsets. How much does each dial move a dial by for every iteration? So the way we're going to do this is that we're just going to have this entire top row, all zero, the 0, 1, just to be all zeros. And how are these over numbers going to change? Well, they're going to decrease every position. This position is going to decrease by 3, this one by 3, this one by 2, and this one by 3. Keep in mind, everything here is modulo 4. So if you take 0, subtract 1, it's not going to be -1, it's instead going to be 3. Because you loop back around to 3. So you take 0 minus 0, 0, 0, 3, each position minus 3, 3, 2, 3. You would then get 1, 1, 2, 0. And then here you would get 3, 1, 3, 1. My brain is stopping. 1, 0. Here you would get 1, 3, 1, 1. And here you would get 1, 2, 1, 1. Now, instead of doing this all the time, I usually prefer to just use textile calculator for this. So I take each of these positions, the ones I need to change. U, 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 and U. Just put them all like this. And just put them all into like a mathematical expression. Each of these positions, I'm just going to subtract 3, 2, 3 from them. And then modulo 4. This. Now I get this answer. There you go. So, just make sure I got these ones correct. 3, 1, 1, 0, 1, 3, 3, 1, and 1, 2, 1, 1. Yep. I'm just gonna quickly remove these. U, and comma space. There we go. And just paste these in. You can manually calculate it, but I prefer to do this way because it's faster. Not really difficult. You just have to set up some things. Anyways, now we have our offsets. Basically, what I mean by offset is that this shows by how much each dial gets rotated. So when it says here that after one press, top left will move it by 1, 1, 2, 0, that means that this will move 1 clockwise, 2 clockwise, 0 clockwise. Then press it again. This, and this position will actually all positions will just be 180. Wait, what? 3, 2, 3, 3. Oh yeah. Okay. It also adds this value. But yeah, that's how offsets work in this. Now what we're going to do is actually kind of find our submission directions. What directions we need to submit. So for this, what you're going to need to tell the expert is just serial number. I can type very well. And also the colors in order. So yellow, red, blue, green. And now in the manual, you're presented with a bunch of these grids. These 4 corners symbolize the colors of the gears. So just scroll down to whichever one you need. yellow, red, blue, green. That's this one. Now, what we're gonna do is we're gonna convert our serial number into hexadecimal. The way we do that is I like to use a number-based converter. You take each serial number pair, so splitting off into 3 pairs of 2. Take each pair and convert it from base 36 to hexadecimal. Let's do that real quick. And echo 7. There. Now we just take the 2 least significant digits, each of these, and there we go. We have our coordinates. The first coordinate is the row, so highlight both of these because there's 2 of them, and the second one's the column, foxtrot. Here. Now you see that in the intersection, we have these 4 squares, which are part of these 4. This is going to be our solution for the first stage, which is going to be 1, 1, 2, 0. And I'll do the same for the other pairs. 0 in delta. That's going to be 1, 2, 1, 0. And then foxtrot, foxtrot, is the very last one, is 2, 2, 1, 1. Since we're trying to get to these positions, but the module already starts off in not all north, but instead into, in this case, west, west, southwest, we're going to be, again, subtracting 3, 3, 2, 3 from our numbers. So, again, we're going to take this number, this number, this number, and just subtract 3, 3, 2, 3 from them. 0, 1, 2, 1, 0, and 2, 2, 1, 1, minus 3, 3, 2, 3. There we go. These are going to be our summation values. There you go. So these values here are how much we have to toggle by to get to our final values. So now what we're going to do is just pick out one number from each of these columns, and only one, that when summed up, all of them summed up modulo 4, will end up resulting in these numbers. I'm going to do for each one individually. So, for this, I'll do one of them manually, and for the other 2, I'll just do an extremely easier method. So let's see. Let's say we're using this column, or this position. So if we're adding this to our total, then that means that from our goal position, the sum of the numbers that we're going to use in these 3 columns would then have to be 0, 0, 2, 3. Is there any way of doing that? So again, then now let's say that we're using this row. Doesn't seem like with the 0 there's nothing. Nothing with this one. Nothing here. And this pair also nothing. Yeah, basically you will find out that if you're using this row and this row, there's no way that you can add up any positions from these 2 that will end up mod 4 result in 0, 0, 2, 3, which means that we're not using one of the rows. So we'll move on. Now let's say we're using this one, 3, 1, 1, 0. 1 free, 1 free. Is there any way of getting 1 free, 1 free? Not with you. 1 free, no. 1 free, 1 free. There. This should work. If you add up each of these positions, I'm going to do like this: 2, 2, 2, 2, plus 3, 1, 1, 0, plus 3, 3, 3, 1, plus 2, 0, 2, 2. This should result in the correct number, 2, 2, 0, 1. And now let's just take the rows for each of these tiles. So here we need to press top left twice. Here top left once, 3 times, and then 2 times. Now I'm just gonna simplify this beyond belief. What I'm gonna do is just set up each of these positions as a variable. So we'll zoom out a little bit. Some more rows. There. 4, top right, bottom left, bottom right. 0, 1, 2, 3. There we go. Equals. I'm just gonna copy these values. You here, you here, you here, you here. Should be able to understand how I'm like why these specific rows are going to these specific positions. But yeah. And now this is just gonna be left here. We're just leaving that here. Now, we're gonna set up that module for whole scenario thing. Our next set that we need to get to is 2, 3, 3, 1, 1. 2, 3, 3, 1. So, let's see. 2, 3, 3, 1. Let's subtract top left 1. Subtract top right 1. Basically, I'm doing the exact same thing, except instead of having to write out these numbers over and over again, I'm just gonna be using like different names for them, which is what I did here. Bottom left 1. No, nowhere to be present. That's not present in. I'm now just gonna be like shifting through these until I find something in here. So I'm actually gonna use zeros here. 0, 1. Nope, that's not present. Here. There. Increases by 1. Not present. Not present. Not. That. Increases by 1 again. Wait. No. No. Yeah. And also no. This again. No. Not present. Not present. Not present. Not present. So now we're looping back around, and now we're just gonna be changing top left. Basically, what I just did here is I knocked out that to get to 2, 3, 3, 1. We cannot use this position. There we go. 1, 2, 1, 1, which matches this position. So, just making sure bottom right 1, this should result in all zeros. Yes. So here we're now just using top left 1, top right 0, bottom left 0, and bottom right 1. And now the same for this one. 3, 3, 3, 2. Again, top left 0, top right 0, bottom left 0 for now. That's not present anywhere here. That's not present, almost. not present, not present. Use this one, not present, not present. No, no. Almost again. There it is. Minus bottom right 1. You should also use null 0. Yep. And for the last one, we're just using this one, bottom left 3, and bottom right 1. There. So 0, 2, 3, 1. Now, you might think that, oh, if you want to get to this position, you press the dials, this one twice and once and 3 times and twice. Then from this position to get to this position, you press it once here and once here. That's not how it works. The reason being is because these rows get offset. Just because you unlocked, let's say that you get to this position for the top left tile, and then you unlocked one of the locks, that doesn't mean it gets reset back to here. It will still continue on from here, which is why I note all of these down instead of instantly inputting them onto the module. So the way we actually get these values here, this one stays the same, but how much you toggle each dial here is that we take this position and we just subtract this one. We take the current one and subtract the previous. So here 1001, we subtract 2132, and modulo 4, of course, 132. And we get 3313. And for this one, same case. 0231. We subtract this one. 1001. The reason it is like this, or an easier way to memorize this, is that let's say that you are, for lock number 1, you used these positions. And for the next, I guess, stage, you need to use this one, for example, on this column. Instead of you just clicking it twice, you would actually need to click it once, because it's just counting how many times you need to move down from your previous position. And if you have something like this, where you have to move down 3 times, because it loops around, it does not go up. But yeah, that's how it works here. And we have our final inputs. So after resetting, if I press this top left dial twice, this on this row, top left twice, top right once, bottom left 3 times, and bottom right twice, I have 1120, which I deleted my notes. Give me a moment. That should be the correct thing that I had noted down. Oh wait, what am I thinking? I already had it. There we go. Yeah, 2201. Oh wait, no, it isn't, because that's the offset. Sorry for my mistake. Here, I was already doing the serial number. Here we go. These were the positions that I got from the manual. So 1120, which means east, east, south, north, which east, east, south, north. That's what I got. Unlock. You see that one of the locks that was, well, present. Little locks here, 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 and here got removed. Now for the next stage, 3313. Top left 3 times. This one 3 times. This one once, and this one 3 times. Should result to 1210, which is what we got. Unlock. And then for final one, 3230. 2211. Exactly what we needed. Unlock. And that is a solved module. A bit of a long one compared to combination vault, but definitely not too difficult once you know the solving method. That's the end of this tutorial. I hope you enjoyed. As always, feedback is always appreciated. Yeah, that's pretty much it. I'll see you all later.